Okay, welcome to this little video on completing the square. Firstly, just two quick fundamentals. Squaring a binomial is something that we very often do, all right? And let's just look at the sort of pattern that exists here. We get the first term squared, we get the second term squared, but then we get twice the product of those two terms. If you're not sure of that, then write the thing out with two sets of brackets, all right? And as an example, let's look at something like, for example, x plus 4. If we were going to square x plus 4, then we would, to be on the safe side, we would write it as x plus 4 multiplied by x plus 4. Right, the x's multiplied together for our first terms give us x squared. This x is going to multiply with this 4, giving us 4x. And this x is going to multiply with this 4, giving us another 4x. And that's where we get this twice 4x. And then plus 16. Right. I think, like many math teachers, if I had R1 for every time I'd seen students forget this middle term, I'd be a super wealthy person. And if I was, I would carry on teaching maths because that's what I love to do. Right. Let's just have a look. So that too, crucially important. Okay. The second little fundamental idea is the idea that an equation is like a set of scales or like a balance. And in order to preserve that equal sign, in order to preserve that balance, we must do the same thing to both sides. Right, let's now have a look at an example. Right, consider the function y equals x squared plus 6x minus 5. And we're going to complete the square to find its turning point and the x-intercept. Now, they're very similar processes, but interestingly kind of different. Okay, let's start off with this one, the x-intercepts. All right. In order to find the x-intercepts, I've made y equal to 0. All right. And now I'm trying to get x equals. So it's a reasonably obvious idea that actually let's add 5 to both sides. All right. To preserve that balance, add 5 to both sides. Now, that's a reasonably sensible thing to do because this does not have any x's in it. Right, this is the kind of the sort of magic stage here. I'm going to write this thing as something squared. Now, remembering that whatever I put here will be squared, so I must put an x. Whatever I put here will multiply with this x and then double. So in order to end up with 6x, I definitely mustn't put 6 here. I must, in fact, halve it to counter that. All right, so there we go. Remember, when we square x plus 3, we're going to get x squared. We're going to get 3x doubled. We're also going to get 9. Now remember that this is an equation. It's like a set of scales. It was balanced. We've added 9 to the left-hand side, so we must add 9 to the right-hand side to preserve that balance. Right, so we end up with x plus 3 all squared equals 14. Now the magic that has happened from this line to this line, all right, is that x went from being in two different places to being in one place. And in terms of us solving for x, that's particularly helpful. Right, the next thing we're going to do to both sides to preserve the balance is we're going to square root both sides. Remember that when you square root, you can introduce a plus or a minus. All right, and then lastly, the thing that we're going to do to both sides is we're going to subtract 3. So x equals negative 3 plus or minus the square root of 14. And those are the x-intercepts of that parabola. Right, let's now look at a similar question, but what we're now going to do is we're going to try and find the turning point of this parabola. So the big difference is that this was an equation. This is an expression for y. I'm going to again try and write it like something squared. I'm going to complete the square. And again, it's going to be x plus 3 all squared. Now, when I square this out, I get x squared. I get 6x. I get 9, which I didn't have. So I must subtract 9. And then I still had my minus 5 here. Now, you might be saying, wow, why here did we add the 9 and why here are we subtracting the 9? Here, we added the 9 to the left-hand side of an equation, so we needed to add 9 to the right-hand side to preserve the balance. This is all on one side of an expression. So to keep the expression equal, to maintain the kind of the sanctity of this equal sign, all right, we need to subtract the 9. Okay, if we now simplify this, we get y equals x plus 3 all squared minus 14. Now, a couple of ways of thinking about this. One is that if we square a number, it will always be positive. All right? It can never be negative. So in fact, the minimum value that this piece here can have is 0. So the minimum value overall for y is minus 14. And that happens when x is minus 3. Because if x is any other value than minus 3, we're going to be adding on something, because this piece will be positive. Another way of thinking about that is just that this expression that we've now got is simply y equals x squared, all right, shifted. Remember that if we add to the x value, the function shifts 3 to the left, and if we subtract at the back, it shifts 14 down. Now remember that y equals x squared would turn on the origin at 0, 0. If we were to shift that 3 to the left and 14 down, that point would now become negative 3, negative 14. Right, and that's the turning point of that parabola. So 2 great reasons to complete the square. There are others, but that brings us to the end of this short bite-sized SIMI video.